Good morning, guys. So, today we're going to be talking about the law of sines. Now, so far, whenever we've worked with sine, cosine, and tangent, we've always worked with right triangles, okay? And that was a very important distinction because what we've learned of SOHCAHTOA and such, where we have the ratios of opposite, adjacent, and hypotenuse, has it only works it only works with right triangles. But what happens when we have triangles that are not triangles, namely an oblique triangle? Okay, so when we have those types of angles, or rather triangles, we are going to be working with law of sines. Okay, now what is the law of sine? Well, basically, as stated here, we're going to have a side A divided by the sine of the angle A. Okay, so when we look at the at this triangle, we have the side A, which is the side opposite to its corresponding angle. The side B is opposite to the angle B, well, to the angle B, this one right here, and the side C is opposite to the angle C. Okay, so the law of sine tells us that this ratio, the side A divided by the sine of the angle A, must be equal to the side B divided by the sine of angle B, and those are in turn equal to the side C divided by the sine of angle C. Okay? Basically, this ratio is the same for this one and for this one with every triangle. Okay? The only requirement is that it is a closed triangle, which we'll see soon. All right, so how does that work? Well, let's solve an example problem right here. Or actually, let's explain an example problem, and then we'll solve one. So here we have our original triangle. Okay, it's giving us, or rather, before we start with this, what do we use the sine law for? The law of sine. We use it to find either a side that is unknown, whether it be side A, B, or C, and we use it to find also the angles that are unknown. Okay, so basically we're going to be using the law of sines in order to solve entirely a triangle, find all the remaining sides and all the remaining angles. That is our goal with this. Okay, so now we go to the example. We are given two angles, 63 degrees and 46 degrees, and we are given only one side, which is in this case 56 inches. Therefore, what are we looking for? We are trying to find one angle and two sides. That is what we have to do. And how do we do that? Well, we begin always, if we have two angles, we should always begin by finding that third angle, that very important angle. And it's quite easy. We always do it by knowing that the addition of all the angles must be equal to 180. So we add these two together and we subtract it from 180. We have 71 degrees. Once we have that 71 degrees, we proceed to use the law of sine. So in this case, we use this ratio of A is equal to C and sine of A is equal to sine of C. Well, sorry, A divided by sine of A must be equal to C divided by sine of C. And then, why do we choose this one? Because it is the only side and angle that we know. Okay, both of them at the same time. We know angle A, but we don't know side A. We know angle C, and we know side C. And we now know, after doing this, angle B, but we don't know side B. So we're going to be using C, and then using that value to find A and B. Okay? And how do we do that? Now, here we go. So we just divide the 56 by the sine of 63 degrees, which in this case, the book tells us that it's Wait, it doesn't tell us yet. Sorry. So before we do that, right, we have to multiply sine of 46 to both sides in order to solve for the variable. So we multiply both sides, and a must be equal to 56 multiplied by the sine of 46 divided by the sine of 63, which is 45.2 inches. Okay, like I said, we have to use a calculator. No more unit circle for now. And are we done? Of course not. We have the side A, but we have the side A, but we are still missing the side B. Okay, so now we proceed to find the side B. Again, we use C because we already know the side and the angle C. And B, we use in order to find it. So once again, we multiply both sides of the equation by sine of 71, cancel here, and 56 times the sine of 71 divided by sine of 63. We use a calculator, and we're left with approximately 59.4 inches. And that is it. That is how we solve this entire triangle. The solution is that angle B is 71, the side A is 45.2 inches, and the side B is 59.4 inches. Okay? Now I'm going to solve one more example, which is from the book.